Again. So as you can see, I pre-loaded this file already with some code similar to what we've done before, except at the top here, instead of 2 slashes like we had for each line of comments like we have here, what I have is a single slash with a star. And notice now all of these are considered a comment, okay? And the way to end it is a slash star. So again, you start with a slash star and you end with a star slash, I'm sorry, okay? And all of this, this whole block is called a block comment, okay? So unlike what we had here. Good. So now let's get to what the objective of this lesson will be. This one here, we're going to explore the various primitive data types that we use in C++. I've listed the ones that I'm going to cover. That would be the short int, long int, long int. And these are the various flavors of integer variable data types that you could create. Same thing with floats, and floats comes in different flavors as well. Float, double, and long double. And then we have a couple particular ones, bool, which is for Boolean, right? So Boolean can be either true or false, okay? Or 0 or anything but 0. So if it's in any other value, it's considered kind of a 1 or true. If it's 0, it's false. So bool is, you got to be a little bit careful with that. We'll pay attention to it in a minute. Char, on the other hand, okay, technically what it is, it's really an integer. So if you have a textbook, you can, for your programming course, you can go to the back. There might be an appendix for the ASCII code for all the characters, right? So each character will have an equivalent integer value that represents it. Your computer does not understand what letter A or B by itself. It associates a number with each one of your letters, either from your keyboard or from your files. All the letters in the alphabet have an equivalent integer value, okay? Can we look at it? Can we actually explore that? Sure, we can do that in this example. So let's hope I don't forget at the end to peek into a character, let's say the lowercase h. What is its equivalent integer value? That would be an interesting little observation, okay? And then you can compare to your ASCII table just to make sure that indeed that was the result. Okay, so as we're going to be looking at these variables, we're going to see how we can use them, okay? In our next video, we're going to look at where and how much memory space they occupy, okay? So we're going to break down this lesson into 2 videos. So we'll have example 5, for example, .cpp, that will look at how memory is allocated for any of these variables. So at this stage, how do we declare and use any of these variables? Let's start with an integer, a simple int. So if you said int, okay, and let's call it num1, semicolon. What you've done here is you've declared a variable, num1, of type integer. Which means now in memory, what you can hold there are values that represent an integer number. Okay? So can we print what's in num1? Can we see what's in num1? Sure. Now I'm going to do this mistake on purpose. Let's say I do this, cout. And let's say I say num1 equals num1 and L. Okay? Now, the compiler is not going to pick this as a mistake. Code-wise, this is correct. Syntax-wise, it is correct. Logically, it's flawed. And the reason it's flawed is because now you're looking at what's stored, or what does num1 represent? Well, I didn't assign anything to it. I declared, so we declared a variable. So this was a variable declaration. and we didn't initialize it. We didn't give it any value, right? And so we just declared it. So it exists now in memory. Your computer knows about it, right? Or your process in a way. And so let's see what this yields. If I compile and run this, let's see what we get. Aha, you get a value. And you're going to say, well, wait a minute. I've never assigned this value to num1. That is true. You didn't. Or I didn't. So where does this 16384 come from? That's garbage that was already in that memory location. Okay? Now, why is this flawed? Well, let's suppose num1 was supposed to be a signal for an alarm, so, depending on what value it has, the alarm will do different things. Well, the fact that it has a value, it might get confused. So a lot of times, if you're setting up an alarm system as an application, you may want to set it to 0 to initialize it. So that means 0, you might consider it like don't do anything. 1, go ahead and set the buzzer off. 2, not just the buzzer off, lock all doors, etc., etc. So, it depends on your application. But 16384 could confuse the whole computer and says, well, what the heck I'm supposed to be doing with this? Or it could mean a specific thing, like blow up the whole building, okay? You're an by mistake, allowed that to happen. Oops, all right? So we don't want that. So a lot of times if you're going to use it, there are a couple things you can do. You can assign a value to num1 before you print it, or you initialize it. So instead of doing a variable declaration, can I do a variable initialization declaration, and let's call it and initialization? And the answer is yes. So you could actually give it a value equals 0. Right, so right from the beginning, you're assigning 0 as a value to num1. Now let's see how this works. So compile and run. There you go. Okay, much better. Now let's suppose I want to declare a num2 of type integer as well, but I will give it a value after I declare it. You could do that, and that simply is a declaration. So you could do something like this: int num2 semicolon, right? So this would be simply a variable declaration, and then you can give it an assignment later on downstream. So num2 equals 9, and this here will be an assignment. So variable value assignment. Or you could say it's simply variable assignment. Right? So you've assigned value to a variable. Can we print what's in num2? So yes, you could do that. We could put it in all in the same, we could do it right here if you want. So we could do something like this. Num2 equals, and this would be num2. You do something like this. We could combine it all into one statement. So compile and run. Let's see how this works. And there you have it. So num1 is 0 because you've initialized it to that value. Num2 is 9 because you've assigned that value after you've declared num2 by itself. Okay? So now this is valid. Okay? Again, in the next video, we're going to see where in memory are you storing any of this and how much memory you're taking up. Okay? So now let's go ahead and declare. So let me separate the program here. So I could put something like this. This will not have no effect on your program. So basically this is really, it's the first 2 slashes that really declare this whole line as a comment. So I like to do it that way to separate logically what I'm doing. So now what I'm going to do now is go ahead and deal with a float type. Right? So a float type would be something like this. So notice I could spend some time here going through short int, long int, long int. We'll leave that for the next video when we try to figure out Why would we want to use long int or short int or long int versus just simply an int? Okay, right. So for now, let's simply go to the basic data types: int, float, bool, and char, and then we'll get into the details of these, including how much memory space they occupy. Okay, so that would make a lot more sense than if I did a short int example right now and not give you the context in which it lives. So we'll leave that for the next video. So right now we've seen what an int is. It's basically an integer variable, right? You could declare and initialize, or you could simply declare and then give it a value as an assignment and then print out. So for float, let's call it num3. Then let's say you wanted to store 7. The best way to do this is to write 7.0. You can write 7, but be clear that that's what you're doing. And what I have done here is I initialized it to 7.0. So this is a declaration and an initialization to a value, right? So it is also a declaration, okay? But I've initialized it to a value 7.0, okay? Can I do another one? Sure, you could do something like this. Const float pi equal 3.14. Now, what did I just do? This also was an initialization, but I'm using the word const, which means now this is a constant. Could I have had also a constant integer? Absolutely. Okay, so you could use a constant, which means you cannot change it. So this is here is a constant. Let me spell this properly, constant. And let's see, what does it mean when we have a constant? Constant, you always give it a value, which means, and notice here, the variable name, try to capitalize every letter of a variable name that is a constant. You shouldn't use the word variable, or should you say a constant? Does that make sense? All right, so make sure you always capitalize this. Here, you could have a combination of characters and numbers, but you always start with a lowercase, okay? I prefer all of my variables, if they're variables, to be all lowercase, okay? We get to see later on what are the appropriate or formats that you could use for variables, okay? So for now, we're seeing a distinct comparison between simply a float and a constant float, okay? So if I want to change num3 to another value, that shouldn't be a problem, to 8.23. And notice if I I'm just going to compile this, just show you that the compiler will not complain about this. Okay, so everything is good. I have 0 errors, 0 warnings. So that's good news. Now let's suppose I go to pi and try to change it to 4.5. Now let's see what happens if I compile this. There you have it. I get an error, and it says assignment of read-only variable. So it's a read-only. You can't write to pi. What I try to do here is write to pi. It's a read-only, right, variable. So you can't, it's a constant, you can't rewrite a new value for pi. So this protects pi from being altered. That's the whole idea behind it. So, so if you wanted pi to use for example, some sine wave calculations or things of that nature, or a circle, the area of a circle or something like that, and you're actually using pi, you want to keep pi as a constant. So the concept of pi is not altered. Okay, so great. So we can't do this. Can we print the num3 and pi? Yes. So cout num3 equals num3, and then pi equals, we're going to do the same thing, and this would be pi and L. All right, well, let's see how this works. So let me compile and run this time. And there you have it. So you're going to say, well, wait a minute. What happens to 7.0? We wrote over it. So another lesson we learned here is you can write over a variable, even if you've initialized it, right? In the first example with the integers, we didn't write over num1, so we simply printed that 0 that was already stored in num1. Okay? Num2, on the other hand, we declared it, and then we assigned a value to it. That wasn't a problem. So we did get our 9. But for num3, which is a float type, we've assigned it a value of 7.0, but that didn't matter because we wrote over it, right? But pi, on the other hand, since it's a constant, we weren't able to rewrite or change that constant value. But can we use it? Absolutely. You can print it out, okay? And it's a read-only variable. Good. So now we've seen what a float allows us to store. So anything with a decimal point versus an integer, anything that is a whole number. But then at the same time, we've learned a little bit how to manipulate any of these two types of data types, right? An int and a float. And again, the next video, we'll get into a little more details. You know, what if I needed to store much larger numbers? And can we prove that actually the space allocated for any of those will be a much bigger or smaller to adjust the size? Okay? So, but for now, we're just following along. We're going to simply do int, float, bool, and char. So let's go ahead and do a bool now. Okay? So again, what I'm going to do now is put a whole bunch of lines here. And let's look at bool. All right? So for bool, and let's call it state. And let's make it equal to true, semicolon. Okay? So either a state is true or false, or a variable name, whatever you want to call it. But the value is either going to be true or false. Now, can we assign it integer values instead of true and false? The answer is yes. We'll see that in a second. So let's see first, what would this print? So if you did something like this, cout state equals. Now, I want you to see this. It's going to be interesting. State and L. All right, so let's see what happens. So let's compile and run. And notice it does not write the word true. It writes a 1 for us. Okay? So now let's change the state to false. So I'm going to do it right here. And let's see what we get out of that. So compile and run. And notice you don't get the word false, you get 0. So 1 for true, 0 for false. So it's really storing an integer. Okay? So that integer is either 0 or 1. Okay, I hope everybody got the picture here. So this false and true is really a label. Could I have written 1 here instead of true? Well, let's see what happens. So compile and run. And sure enough, I get the same result. So 1 for true, so you can actually put a 1. Can we put a 0? Absolutely. Now I'm going to show you what else you can put in here. So let's compile and run. And you get a 0. Okay? So now let's put a value other than 1. Since it's an integer, so you should be able to put 5. So what would the state be? Now notice I've made state equal 5, but it's Boolean, so compile and run. And notice it changes state back to 1. Okay? Even though we gave it a value of 5. As long as it's greater than 0, then it will have a value of actually 1. Okay? So you could write the word true, which is a keyword, or the keyword false, again, which is a labeled keyword, right? Or you can actually use integers. So for a Boolean variable, As long as it's 1 or higher, it's going to be true. So now let's put a negative value. Let's put a -1. Let's see what happens. So compile and run. And notice, other than 0, it still is a what? A 1. So the only time it's false is when you put a 0. Any other value, it's true. Okay? So again, let me put a false here. Let's see how this works. Compile and run. Okay? So the only time you're going to get a 0 is when you put false or 0 for the state. Fantastic. So now let's look at characters. So char is the data type. And my letter, and that, let's suppose we want to initialize it. So to initialize it, if you want to put a letter there, let's put a lowercase h. Notice this single quote, not two quotes. This is not a string. This is a single character. This was initialized to the letter H. Well, let's see if we can print it out. So cout. Okay. And my letter equals, and then you could put my letter and down. Now let's see what we get out of that. Okay, so compile and run, and you get your H. So it's as simple as that. It is a variable. You can actually change the value anytime downstream or anytime you want to do any of this, right? So you want to change it to another letter, you can. All right, so in our next video, we will explore the various flavors of these data types and how much memory space they occupy. Okay, fantastic. So I'll see you then.